most probably we would have even done the sizing, assuming that we would be reaching a certain scale, let's say 6 months or 1 year down the line. And when actual processing started, we would have realized that the actual compute that is being used may be just 10% of what we estimated. So in terms of right sizing and also the billing, that is where we also get this benefit of micro billing. So we pay only for the compute for the duration where we are using the serverless compute capabilities. With that, let's look at some of the capabilities within Azure. So that was serverless in general. So what I spoke just now about event-driven and instant scaling, micro-billing, this applies to everybody, whoever is doing or offering serverless capabilities, be it AWS, Google, or any other cloud provider. It applies to everybody. Now, in terms of serverless on Azure itself, there are different services which offer serverless capabilities. Many people have this misconception that serverless means you have to have function as a service. And if you write function as a service or fast, then you are serverless compliant. That's not really the case. That is just one part when we talk about serverless. Let's see which are the areas or which are the different categories which come under serverless. So specifically talking about Azure, there is the serverless Kubernetes option where we can elastically provision pods or the workloads inside the serverless offering of Azure for containers, which is called as Azure Container Instances. And this works on the basis of a virtual node. So virtual node is an open source project which is based on a virtual kubelet. There is a project called Virtual Kubelet, and this virtual node capability is built on top of that. And to add to this, we also have a project which is called as KEDA. This is adding the event-driven capabilities to the processing of events, which are not just part of the Kubernetes cluster, but it can also scale the containers or pods based on event sources which are outside of the Kubernetes cluster. So we will look at an example during today's session. The last demo that I'll be doing would be the serverless capabilities of AKS as well as this SCADA. The other feature is serverless function. So this is what I was talking earlier about the function as a service. This is purely based on event-driven computing. So we have support for multiple languages. We can write functions on Azure using C#, Java, Python, JavaScript, PowerShell. These languages are natively supported. And we pay only for the time when this code is executing. And all of this, the function runtime, is open source. So what this enables us to do is, this is not restricted just to Azure. We can deploy this on different kinds of environment. We can deploy it on Kubernetes. We can deploy it on the IoT edge. This can be deployed on on-prem, and this can also be deployed on the other cloud providers. The next option is the application environment itself. And this allows us to run and scale the web, mobile, or API applications, and it provides high productivity and a fully managed environment. What this does is it gives us a kind of sandbox environment where we can choose what operating system we want, be it Windows or Linux, and then what should be the compute and networking capacities. There are different SKUs, stock keeping units available under the application environments. And based on that, we can choose whatever SKU we choose, we would have different capabilities allocated to that particular environment. So let's focus our energy on Azure Functions and look at some of the scenarios where we can use Azure Function. The most common or use case for Azure Function is for doing something on periodic basis. Let's say a use case where every 15 minutes, we want to have a scenario where we want to clean up some invalid data. We might be having, let's say, web sessions stored inside a database, and those sessions are expired. We have orphan sessions, and we don't want to keep them in our database. So we can run a process, or we can run a function which runs every 15 minutes, and it cleans up this table. So any invalid sessions or any orphan sessions which are expired, these are cleaned up. The other scenario where we could use this is, instead of timer, we can use an event. So let's say a file is added to the object store, blob storage, for example. And every time a file is added, this could be a CSV file. which contains, let's say, a number of records, which we want to transform into data rows. And then we want to project this into a Power BI dashboard in real time. So this is a scenario where instead of running it on a trigger or instead of running it on periodic basis, we wait for an event to occur, which is the file being added to the blob storage, and then trigger the transformation to happen as part of the Azure function. The next scenario is in a mobile app kind of application where we use something like, let's say, Instagram. We have an app which is similar to Instagram, for example, or Facebook for that matter. We take a photo and we upload it. And this is similar to the previous case where instead of a CSV file, now we are storing an image or a photo in blob storage. And then we want to produce different scaled images. So we might want to, let's say, create different sizes of the images, a small, medium, large, extra large kind of thing. And this can be then used in different form factors, depending on which is the target device which is seeing this particular image. Similar to this, we have another scenario, which is loading of a web page, and we can call a webhook. Let's say a person logs in into a shopping site, Lazada, for example, or any of your preferred site, and you have a profile created in this particular shopping site or the website. And the site already has your information. Let's say your gender, it knows what age group you belong to, what are your preferences. You might have chosen some certain categories where you would like to get some promotions, or you might be interested in certain kinds of products. So based on that, now instead of showing just a random ad, we could personalize the ad and target it to a particular user profile, and then serve that ad onto the app. So these are different scenarios where we could use Azure Function. I would like to share with you one of the scenario which I use personally, which is to delete a resource group. So the scenario was, I was creating multiple resource group for various demos, and a resource group is a concept in Microsoft Azure which allows us to logically group different resources. So anything that I create for the demo is usually put inside a resource group, and it contains all those resources for a particular session, for example. And in the past, I used to have very limited number of credits available for Azure. And once it so happened that I created a HD Insight cluster, which has a lot of powerful VMs underneath it. And I almost wiped out my whole account credit within a couple of days because I forgot to delete that particular resource group. So in this scenario, what I'm trying to do is every day, I run a function which checks if the resource group that I have created contains a prefix called delete me or demo. And if any of this condition is met, I go and delete that resource group. So this is like an indicator for me to create resource groups and resources when I'm creating them. And if I want to delete them automatically, even if I forget for a day, this process which runs, or this function which runs the next day, it would automatically delete that resource group, and I will have very little uh, consumption. So let's look at this demo. Are you able to see my screen? Is the size okay for you?
Yes, for me. I don't know if everyone. I think if anybody cannot see it well, please give a shout.
Okay. So I assume it's okay for everybody. Let's start by looking at how do I create a function app. So in the Azure portal, you can go on the home screen and you will have this option to create a new resource. You click on that, and the type of application or the resource I want to create is a function app. And I will get this familiar screen if you have seen the Azure portal before. Initially, we are supposed to provide this basic level of information about which subscription I want to use, what is the resource group which I want to create. So let's say I want to create that demo and serverless SG. And let me name this as serverless SG RG as the resource group. Then I need to provide what is the name of the application or the function. So let me name it as Serverless SG fun. And in terms of publishing the code, I have the option to publish it as a code itself, or I can also use Docker container. So as I said earlier, that function runtime is available as open source code. So we also have the option to containerize the function. And instead of writing code into the portal itself, we could create a Docker image and we can use that. For the purpose of this demo, I will use the code option here. And then when, we have to choose which is the runtime I want to use for this particular function. So I have the option to choose from .NET Core, Node.js, Python, Java, and PowerShell, as well as there is a custom handler. So if none of this is applicable to me, I can also create my own custom handler to handle this function. So let's say I want to use Node.js as an example, and then I get to choose which is the version of Node I want to use. So currently version 14 is in preview, and we have long-term support for version 10 and version 12. So if I choose, let's say Python, for example, as a different runtime stack, then again, I have the option to select between 3.6, 3.7, and 3.8 version, and so on and so forth. So depending on the type of runtime stack, I will get options to choose one of the supported version from that. And then we have the region where this function would be created. So I will choose Southeast Asia for Singapore. Once I have chosen these basic setting, the next thing to do is about the hosting. So I can host this function in different plans. I can choose the serverless plan or consumption-based plan, which is the default one. I can also choose a premium or app service plan. And depending on which plan I choose, the capabilities or the features which are applicable for this function, they would vary. If I choose premium, for example, I would have the capability to deploy this function within a virtual network of my own. So those are the kind of additional features I get based on the type of plan that I select. So let me go and select the consumption-based plan for now. And if I'm okay with the other things, like if I want to enable monitoring and I can put some tags, finally, I can do review and create, and this will create the function. So in the interest of time, I will just go back and use one of the function which I've already created, which is to delete that resource group. So if I select this function, you will see that in the overview pane. So in Azure portal, we have these two types of panes. One which is called as the control pane, where we have access to all the management kind of features like the overview, the tag, security, and then there is the data plane, which is the actual code or where the actual functionality resides. So this is mainly the control plane where we see the details about which resource group is associated with this particular function, what is the URL where I can call this function. So let's say I want to integrate this function with some other application, then I can use this URL and I can either use the SDK or I can make REST API calls to this particular URL and this function would be triggered. And it also gives me option or details about what is the plan which is being selected. So in this particular case, I'm not using the serverless option, but I'm using the app service plan because this particular function is written in PowerShell. And when this function was written, there was no support for the consumption-based plan. So I had to choose this app service plan. So that is at the high level. I can also do things like stop this function from running. It's like stop it currently and then restart it at a later point of time if I want. So enable, disable kind of feature is available. And then we have other options like security events and things like that. But let's focus on the code, which is the core part of functions. How do we trigger the code? So I have under the functions, there is one function which is called as the delete resource group here. And this is based on the timer. So as I showed in my slide, this runs every day. And the current status of this is enabled. So if I click on this function name, I will get again the overview of that function. And then from a developer point of view, I have the code and test capabilities and then integration and monitoring. So let's look at the code of this function. So this is the PowerShell code which runs every day. So there is a timer which is passed as an input or the binding for this particular function. It checks what is the user time. It converts it into the UTC time. And then it checks if there is in my resource group any resource which has delete me as a prefix or demo as a prefix. And if it finds any of these, it adds it to a collection and then just loops over it and calls the remove AZ resource group PowerShell command to remove that particular resource group. So this force will forcefully remove that resource group if it exists. And that's all. So this particular script is like, I don't have to deploy it into any environment. Once I put it here, this is running as part of that function runtime, and every day this will be taken care. I don't even need to know which machine or which server this particular code is running on. Now, in terms of integration, if we look, it will show us what are the different integration points this particular function has. So the trigger for this is the timer. So all the functions, as I said earlier, these are event driven. So there has to be some sort of trigger to trigger that function. And in this particular case, the trigger is a timer, which is a daily trigger. And we can also define inputs. So apart from the timer, let's say my function requires additional input. I can add those input parameters here. Then the actual function, which is that delete resource group. And if I want, I can also write this output into some sort of output. So this input and output, these are called as bindings in Azure Function. And once I've developed this function and I've deployed it, I've started that, I can monitor this. So you can see here that in the last 30 days, there have been 29 successful executions of this particular function. And I can see daily, so like on 19th, this has ran for about 28 milliseconds or 29 milliseconds. On 18th, similar time. We can also look at the log, exactly what happened during that particular function execution. So it gives us some information, some warning, and it also puts the log entry that I wrote in my function. So this information is coming from my function, the log that I'm writing. And in this case, you can see that there is no removal of the resource group because I did not have any resource group which was named demo or delete me. Let's look at one of the resource group or one of the execution where there was a resource group involved. So I think on 4th, there was one case. So here we can see that this ran slightly for a more period of time. Instead of finishing in less than 30 milliseconds, it took about 35 milliseconds or so. And here we can see that it found out a resource group which had this demo-ossconf as the name in the resource group. And it has gone and deleted that. So this is how we can monitor the execution of a function. And we can also have things like logs. If the function is currently running, I can actually connect to the log stream and I can see what is happening right now if the function is currently being executed. So that was about the Azure function. Let's go back into our demo slides and look at some other details. So as I said, in case of Azure Functions, we have these triggers and bindings, and there are different runtime versions of the Azure Functions available. The initial one was 1.x, and now we have runtime version 3x available. So based on the capability of the runtime, we have these different types of triggers which are supported, like blob storage. There is Azure Cosmos DB, there is Dapper. Dapper is specifically for Kubernetes. So the trigger input and output capabilities, they vary based on the type of the source. And we can have at times all three supported. Like in case of Azure Cosmos DB, it can be used as a trigger, it can be used as an input, it can also be used as an output. But in some cases, we only have the capability to use it as a trigger and output. Say, for example, the queue storage. We cannot use this as an input. So this is done using something called as bindings. So bindings are of two types, input and output. And I have a link here. I think because of my taskbar or status bar, that link is not visible, but you will find this particular link where the details about these triggers and bindings are available in the Microsoft Docs. I've already published these slides on the speaker deck, so you will be able to find it over there. Next is the default timeout. So Azure Functions, based on the runtime version and based on the type of the plan that we select, it has a default timeout. And if the function doesn't finish within that default timeout, it will automatically be terminated. This is to make sure that we fit within our consumption plan and we are not running some function which is supposed to be finished within, let's say, 5 minutes, for example, and it's taking a lot of time. This is to avoid a scenario where compute is being consumed for longer duration than expected. So the default is 5 minutes for the consumption plan. The premium based on the version of the runtime, we have like 30 minutes as default. This is in minutes. And for the app service plan, we have unlimited for 1.x, but for 2 and 3, it is 30. We can override this by means of configuration, and we can set the maximum timeout to 10 minutes for the consumption based plan and unlimited for the others. There is also a concept of durable functions in Azure Functions. So let's say you really need a capability where you cannot finish things in 10 minutes and you would like to have a slightly long running process, which still needs to be triggered based on some sort of an event. Then we can use this concept of the durable functions. And that follows a slightly different pattern in terms of execution. Now, let's move on to the next category of services, which have the serverless capabilities in Azure. When it comes to the workflows, we have serverless workflow orchestration. This is called as Logic App in Azure. And this allows us to integrate data between different applications. And this is giving us a workflow management. We can visually build a workflow and we can integrate data from different kinds of systems. It can integrate data using APIs. It can integrate with serverless functions. And out of the box, there are a lot of software as a service connectors. So this is mainly used for scenarios where you want to connect to external data sources and you want to build a workflow around that. And in the demo, in a few minutes, I will show you what are the different connectors which are available out of the box. The next service which has serverless capabilities is the API management. So the API management of Azure, we can use it to publish, we can use it to secure services, APIs basically, transform, manage, and this is fully managed service. So again, we don't need to deal with any servers. We don't need to deal with patching, upgrades, anything like that. This is all managed and we use it for our own APIs. So this supports advanced features like SSL termination. You can have rate limiting, throttling, all those kind of things which we expect from modern day API gateway. These are provided by the API management. And then if we are looking at reactive programming, where we are writing code which doesn't do request response kind of scenario, and we are writing code which is based on, let's say, reactive manifesto, where we base our processing on the callbacks. Then we also have Azure Event Grid, which is supporting event-based applications. And there is also Azure Service Bus, which is used for distributed and scalable cloud computing solutions. This caters to both private cloud as well as public cloud. Now, let's look at an example of Azure Logic App. And this is again from my personal experience, where I built a Logic App to automatically write an email reply. So the scenario was I had this account with a bank, and uh, by mistake, my email ID was tagged to somebody else's account, and that person was defaulting. And I was getting a lot of emails from the bank saying, your credit card has pending due amounts, your policy has so much amount to be paid. And this was coming quite regularly, and it was really irritating for me. And I tried contacting the bank and asking them to stop sending these emails and update the right person, the email of the actual account holder. But somehow that didn't happen. So what I did was to create a Logic app, and to build a autoresponder. Every time I got an email from that bank, this logic app would respond back. So before I show you that code or that workflow, let me quickly show you how to build a logic app or how to create a new logic app. So again, I go into create new resource and I say I want to build a logic app. And I'll be presented with a similar options where I need to choose what is the resource group and where do I want to deploy this. So again, let's use the same thing, which is serverless SGRG as the resource group. And then let's say the name of the app is serverless app. And the region is Southeast Asia. And that's pretty much to create the logic app I need. And based on this, I can also just add log analytics if I want, which will add some telemetry. And I can add the tags, which is again a common feature. And when I click on review and create, a logic app would be created for me. So again, I will go back in the interest of time and use a pre-created logic app. So I have this logic app, which is called as the bank name autoreply. And currently this is disabled because after about 1 or 2 months of running this particular workflow, the bank took an action and they are no longer sending me those emails, but I have still kept this as a backup. In case they start sending it again, I will enable this. So similar to the function app, we have the control plane here, and then there is a data plane, which is coming as a logic app designer. And when I click on the logic app designer, I will get a canvas which shows me what are the different steps I have in my current workflow. So this particular logic app is again on a recurring basis. This is not based on any event. I've scheduled the frequency as 1 day. I have the option of adding some additional parameters, like if I want to add time zone, start time at a particular hours and things like that. But for simplicity, I'm just keeping the frequency as 1 day. And then the actual step which takes place every day is it looks at any new email in my Gmail account. So I have an API connection which is established to my Gmail account, and I look at my inbox, and there are various parameters which this particular task supports. So I can say the subject if it is or the sender if it is from this particular email, use that particular filter to filter only emails which are coming from this account. And I can also do dynamic things. So if I have, let's say, dynamic content to be added instead of just a static text here, if I want to use some sort of pattern, I can also add dynamic expressions here. Then I can filter on the subject. I can use parameters like the importance, if it is starred, if it has an attachment, and once I've selected that, the next step for me is to automatically reply. So I have another task as part of this Logic App Designer to reply to an email. I use the same connection, the API connection, which is built to my Gmail account. And then I take the input from the previous task. So here I get access to all the things like the message body, from the message ID, sender's name, and whatever is available as part of the metadata of that particular email. So I can use that and I can build my expression or the body of the email. So I put whatever text I want to put here, and I also put this as an attachment, the original email. And I provide additional details like to whom it should be sent, to whom it should be CC. So this is the three-step workflow, or actually two-step. Every morning, trigger this job or this workflow and filter the incoming email messages. If there is anything based on that filter, I will automatically reply with this content. So that is how I build the workflow, and then I can just schedule it to run. Let's say I want to add some new step. So when I click on this new things which come out of the box conditions, so I can also do things like check for a specific condition, like if else kind of scenario. I can also do looping. So I can, if let's say I have some collection over which I want to loop, then I can do for each kind of loop as well using these built-in controls. And then when it comes to the connectors, let's look at the built-in connectors that we have. So we quickly had a look at the control and the HTTP. We also have the option for things like inline code. But if I expand this, you can see that it has support for Azure Functions, API management, app services. So all these are Azure specific things or easily integrated with Azure. Then if we go into the standard one, we see that this is where the software as a service or SaaS capabilities comes into the picture. So we have things like Adobe Creative Cloud, Adobe Sign, uh, there is Amazon Redshift, you have Apache Impala. So all these connectors are built in and they are provided out of the box for us. So I can choose any of this, and based on what I choose, I would get the actions associated with that. So let's say I choose Azure Monitor, for example, then I can run a query against Azure Monitor. These are the two types of actions which can be triggered on the Azure Monitor. So let's say I don't want Azure Monitor, but I want to use something else. Let's use some third-party one. Uh, there is Bitly, there is Buffer, there is Box here, there is Blogger. So let's say I want to do something on the Blogger. So if I select Blogger as my connector, so you can see every time a blog post is created or deleted, a post is edited. So all these kind of events can be captured, or I can respond to these kind of events which are supported as part of that particular connector. And let me quickly show you the number of connectors which are there. So if you do the math, you can see that the standard part, I think there are 7 columns here. And let me just expand this. You can see the number of connectors which are available. So I think last time when I counted, this was close to 200 plus. And this covers various things like we have this messaging services, there is storage services like Google Drive, there are project management tools. Uh, you can think about almost anything that is commonly used nowadays, which has an API connection, is mostly available as part of these standard connectors. And then we also have the enterprise ones. So there is support for SAP, there is support for message queue, and there is also support for IBM 3270. So based on, as I said, what connector we choose, we get different kinds of triggers. So that was about the designer. The other benefit of using the Logic app is we can also get the code view. So if we are looking at things like doing continuous integration and continuous deployment, then we can extract this code which is generated behind the designer, and we can store it into, let's say, our source control. And this can be used to provide different parameters. It can be parameterized, and we can use it as part of our CI/CD, deploy it into, let's say, UAT or testing environment and production environment as part of the pipeline. There are also templates which are available. So the common kinds of triggers which we use, these are available as built-in templates. So let's say if we want to do something when a new tweet is posted, or let's look at some other one where we have something in terms of email. So in an enterprise scenario, let's say we get an email and it has an attachment which we want to put into a SharePoint list. So those kind of things which are commonly used, or let's say, for example, when a file is created in Dropbox, we also want to copy it to a secondary online storage like OneDrive. So it provides us with all these kind of default templates, and we can build our workflow on top of that. And the last thing which I wanted to show you with Logic App here was the connectors. So let me just close this. If we click on this connector, this will open the documentation page, which will show us all the connectors, what are their limitations, what are the capabilities that we can use with those connectors. So I would also recommend that if you are interested in using any of those connectors, you can first go through this connector capabilities and see if it meets your requirements. With that, let's go back into the presentation and continue from where we left. So that was about the email auto reply using the Logic app. So as we saw, Logic app, it's like integration as a service, and it can connect to Azure services. It can also connect to other third-party services, and it also has this enterprise capabilities where using the on-premise gateway, it can also connect to the on-premise sources. So this can be a very handy tool when you want to connect all this software as a service services and you want to build some workflows using a visual designer. Next on the list of services is the AI and ML capabilities. So there is a lot of support within Azure for cognitive services. Like if you want to build applications using things like what the apps can see, hear, speak, and understand and interpret the natural language processing. These kind of services are available as a toolkit, which is the Azure Cognitive Services. And we can integrate our applications with these Azure Cognitive Services using the APIs, or they can also be deployed using containers on Azure Kubernetes Service. They also provide SDKs. So we can use common programming languages like C#, Java, Go, and we can integrate Azure Cognitive Services using the SDKs provided for these languages. Next is the conversation part. So nowadays, if you go on any site, you would usually see a pop-up coming up and saying, hi, I'm so-and-so, do you need any help? And if you are from a technical background, most likely you know that it's a bot which is trying to help you with some frequently asked questions. So that capability can be built on Azure using intelligent bots with the help of Azure Bot Service. And this can integrate with things like text or SMS based services. It can integrate with Skype, Microsoft Teams, Slack, Office 365, Twitter. All these are supported out of the box. And the last one is the machine learning models. So there is this service called Azure Machine Learning, which provides built-in models for different kinds of machine learning uh, uh, algorithms. And this can be deployed on cloud as well as on the edge. The next category of services is the databases. So when it comes to databases, there is the serverless Azure SQL database. And if you look at the offering of Azure SQL, there are different modes in which the SQL database can be deployed on Azure. So by default, there is the cloud-only version, which is the Azure database or Azure SQL database. There is another version of it, which is called as the managed instance, which is similar to the on-premise one. It almost has 100% feature parity with the on-premise or the regular SQL Server. And then there is an option where you can have a virtual machine on cloud, which has exactly same like on-premise SQL Server installed. So within the cloud provided Azure database, there is this option of choosing serverless, or one of the stocking keeping unit is the serverless capability. This is optimized for price performance ratio, where we can choose what is the range of the compute we want or the processing power, mainly virtual cores, and this scales automatically based on the workload. So assume you have a database which is not used very frequently. There is no predictable load on that particular database, and you want to reduce the cost. If you go with a standard Azure SQL Server, you will be charged based on the overall database units, which is the combination of your storage, compute, and networking cost. In this case, we can scale the compute based on the demand, and we pay only for the compute that is used. And let's say going back to the earlier scenario where you don't need this database to be up and running all the time, assuming this is used on weekly basis or on a monthly basis, you can also pause this database and you pay only for the storage when this database is inactive. And all this is automatically updated because this is like a platform as a service offering. So the platform takes care of all the upgrades. It has built-in high availability, security, as well as performance, which is based on ML engine. So we have advanced threat protection and all the advanced capabilities as part of the Azure SQL. And then there is the globally distributed, massively scalable multi-model database, which is Azure Cosmos DB. This is having only one way, which is the serverless option. So there is no multiple ways of deploying Azure Cosmos DB. So let me show you a quick demo of how to provision Azure SQL database with the serverless capability. So again, same way, going back to the home screen and creating a new resource. I can search for SQL database here. And then create. So the initial part is same. So instead of doing that process over and over again, let me choose the existing resource group here to save some time. Then I can provide the name of the database here. So let's say serverless SGDB as the name. And then I need a logical server here. So let me create a new logical server. I also need to provide the name of the admin account. So I'm giving SQL admin as the name, and then a highly secure password. And then finally the location, which is Southeast Asia for us, for Singapore. So this will create a logical server for us. And then the compute and storage option is where we get to choose what is the capabilities we need for that particular SQL server or the database that we are creating on that logical server. So if you see here under the general purpose, we have the provisioned, which is the default here, but I can change this to serverless and uh, have a watch on this part. So this is a general purpose 5 size, or the SKU is this one. And the cost per gigabyte in USD is 0.14 cents into the maximum storage that I select as the storage capacity. And this is estimated currently as 5.74 USD per month if I run with this configuration, which is 1 vCore and as the maximum, and minimum is 0.5. So let's say I want to use 16 virtual cores instead of one as my maximum capacity. That is what I'm estimating my maximum workload to be running on this instance. And then I want to say minimum virtual cores I need to assign is 3. Then I can also select the auto pause feature, saying if this is not active, if there are no queries running, let's say for 4 hours, I want to automatically stop this. And maybe 32 GB is not enough for me. So I want to have the data size as somewhere around 1 terabyte, 1.85. So now what you will see is based on this, it will automatically recalculate the estimated storage cost and the monthly cost for me. So if I use this configuration, now I will be paying close to 350 USD per month. And this would again vary based on if I use the auto pause feature. If the database is not in use, then it would charge me only for the storage, which is that close to 1 terabyte. It will not charge me for the compute. So that was about the serverless database. Now, okay, I will not create this because I don't want to spend some money on that. But that is how you create a serverless database. Now let's go back and look at the next option, which is the storage. Now, in Azure, we have similar to S3, the blob storage, where nowadays storing the static websites and using blob storage as the storage mechanism for static content is becoming quite popular. That's one use case where if we have static web content is stored inside the Azure blob storage, and then we can use things like API management and function apps to trigger any dynamic things that we want to do. That's one pattern which is being gaining popularity of late. But apart from static web apps, we can also use this Azure Blob Storage to store massively scalable unstructured data. Anything related to, let's say, PDF files, the audio files, video files, those can be stored in unstructured data format on the blob storage. And what that allows us to do is to use these storage event capabilities to perform some operations. We have all these events which can be monitored or which can be tapped into, like when the file is added, when the file is deleted, if there is some renaming happening, if the metadata changes, any of those kind of events, they can be pushed into things like event grid. And then there could be subscribers who subscribe to that event grid, and they can have logic app triggered or function app triggered, or there could be a custom HTTP listener which listens into these kind of events. The last two services which offer serverless capabilities are monitoring and analytics. So under the monitoring, we have Azure Monitor, which is an extensible application platform management service, which allows us to collect, analyze, and act on the telemetry data. And this is not limited just to the cloud. This telemetry data can also come from on-premise, and we can use the Azure Monitor to build workbooks. We can use it to build automation, which can help immensely to improve the availability and performance of the application. And finally, in terms of the serverless analytics capabilities itself, we have the stream analytics, which allows to process massively parallel real-time analytics data. So anything that we want to do in terms of processing large quantities of data, which might be coming, let's say, from IoT devices or other real-time sources, we can use stream analytics to process that. And this has native integration with Power BI as well. So we can get real-time dashboards which are triggered or which are powered from Azure Stream Analytics. Now, with that, I almost come to the conclusion of these services, but I would like to show you one interesting demo, which is the first part, which I talked about, the Azure Kubernetes service talking to Azure Container Instances, which is the serverless offering on Azure for creating containers. And then we also integrate Keda with this. So I've been using this application for quite a long time, where I have a RabbitMQ cluster or RabbitMQ broker, where I publish certain number of messages using a producer. This is a .NET Core API. And then there is a .NET executable, which consumes those messages in a batch. And this is deployed onto a Kubernetes cluster on Azure Kubernetes Service. And I use a feature called Virtual Node, which allows me to schedule the workload specifically on Azure Container Instances. So instead of running these consumers on a Kubernetes cluster, the VMs which are allocated to a base Kubernetes cluster, I use the serverless power of Azure Container Instances to schedule this workload. And we will see this in action. I've created multiple demos or multiple videos around this particular Keda as well as virtual nodes on my YouTube channel. So I would recommend that if you are interested in knowing each and every minute detail of how this is set up, you can go have a look at those videos. But for the purpose of this session, I will quickly show you how this works. I've already set up this and deployed all the services, all the components of that application onto the uh, Azure Kubernetes Service instance. And let's start by looking at what are the instances, container instances, which are currently running. So if I refresh this page, you see that I don't have any Azure container instances running at the moment. That means there are no workloads which are scheduled to run on this platform at the moment. I will also go back into the UI. So I use a tool called as Octant, which gives me the visibility into the Kubernetes cluster. And here you can see that currently I have only 3 pods running. One is for the RabbitMQ service itself, and the other 2 are for the RabbitMQ producer. So I don't have any consumer running at the moment. And I also have a RabbitMQ UI, which shows if there are any messages in the RabbitMQ. So the way this application works is when I push some messages onto the RabbitMQ, there is this framework or there is this tool called as KEDA, which looks at the RabbitMQ as an event source. And if there are any messages to be processed, it will look at how many messages are there to be processed. And based on the number of messages, it will automatically scale up and it will also scale down when all those messages have been processed. So to pump in messages into this RabbitMQ, I will call the API, which triggers the message. And before that, let me just go and put a watch on the number of pods as well as the deployment. So you can see here that this deployment was done about 5 hours ago. So both the consumer and the producer has been deployed about 5 hours before. And that's the template which is used. Deployment is a high level construct in Kubernetes, which defines the template in which how my pod or the workload has to be scheduled onto a Kubernetes cluster. So right now for the producer, I requested for 2 instances of the producer to be running and both of them are ready and up to date and they are running. Whereas for the consumer, there is nothing running at the moment. And here on the pods also, we can see that I have the RabbitMQ pod, which was created at the same time as the producer. And since I put a watch, if there is any change in the state of the pod or the deployment, we should see the updated messages here. So let me go into the Postman, which allows me to make a call to this API. And let me publish 1,000 messages. So I'm sending a request to populate 1,000 messages into that RabbitMQ. If we get the status as OK here, we should be good, but we don't get status OK. That means there is some problem. Let's see if everything is running fine. Okay, so I'm doing a port forwarding for that service, and right now that service has stopped. So let me start that port forwarding again. Okay, now if I go and regenerate this, we should get 200 as the response. Yeah, we got 200 as a response, which means the request to populate those 1,000 messages has been sent. And if I go into RabbitMQ, this is refreshing every 5 seconds. So we should see 1,000 messages being populated into this particular RabbitMQ. Okay, I know what's happening. So the RabbitMQ port forwarding has also stopped. So sorry about that. Okay. Okay, this is up and running now. So if we go back into the RabbitMQ, we should see, yeah. So you can see a spike here and we have 1,000 messages ready to be consumed. And if I go onto that watch, we should see some action happening on the 2 watches. So you can see that now the consumer has started to scale in. And initially it started with a request for 1 consumer, then it went up to 4. And none of the consumers are ready right now because this request goes into that serverless ACI infrastructure to create a pod, and it takes few seconds. You can see that it's taking about 24 seconds and still going on because it will provision that infrastructure. And while that infrastructure is getting provisioned, we will see that the deployment scales. It realizes that those 1,000 messages, none of them have been picked, and it requests for the progressive increase in the deployment here or the instances. So from 16, it would go up to 30 because the limit that I've specified in my configuration is 30 instances. And you see that periodically these deployments, they are getting in the ready state. So that's on the deployment. And we also see on the number of pods here that within about 30 seconds or 34 seconds, we have some pods which is up and running. So here, some pods have been provisioned and they are already running. If I go back into the Revit MQ UI, we see that the messages have already been picked. There are 11 consumers so far, or this will keep changing as and when they get ready. But each consumer is picking 50 messages in a batch, and that's why the number of consumers into 50 are the number of messages which have been picked up. And if I go into the container instances now and do a refresh here, I should be able to see some container instances up and running. So you can see all 30 have been requested, and some of them are already running, some are pending. So within a minute or less than a minute, I have been able to provision container instances and schedule a workload to run on them. So that is how fast we can provision resources or compute on demand using this virtual node and ACI containers. So I will not wait for all these messages to be picked up. In fact, they all have been picked up. But if you go back and look into my demo on the YouTube, you will see that once all these messages are processed, these consumers from 30, they will start to scale down back to 0. That is what is the configuration which I have set up again, that if there are no messages after a period of time, there is a cooling off period where the scaling down happens. And as a result of that, I will be charged only for these container instances for the period of time where they were up and running. So that was the quick demo of showing how we can use the Azure container instances to scale dynamically a burstable scenario into this serverless mode. So that was pretty much in terms of the different demos that I had to show. Now, in terms of the platform features itself, we see a lot of integration with the developer tools. So what I showed was mainly on the Azure portal, but there is the SDK is available where I can download the SDK and I can develop locally. There is integration with things like the Visual Studio. There is also integration with Visual Studio Code, which is nowadays used commonly for many cross-platform applications and languages. And we have support for local development. So things like Azure Functions, they can be developed locally, they can be tested locally, and we have integration into monitoring as well. Like I showed in the Logic app or the Function app, we can monitor what happened, and all these services like database, storage, security, they all have integration into this whole platform. I will also quickly show you one of the things which we can do with the Visual Studio extension. So there is an extension for building function apps. So if you install this extension called Azure Functions, then you get this capability where within the Visual Studio Code itself, I can go and create a function app. So when I enable this Azure function and I go into this Azure here, you can see create new project, and there is this capability of creating a new function. I can connect to my Azure subscription, and whatever I do from here would be happening in that Azure subscription. And then if I want to deploy that function app onto the cloud, I can use this deploy capability. So that is how you can develop, you can test, and you can integrate into your favorite integrated development environment. So with that, I come to the end of this session. If there was any takeaway I would like you to take, it is this, that on Azure, there are various services. It is not just the function as a service or FAS that is serverless. We have compute, we have database, we have messaging, which are all available as serverless. What this allows us to do is it offers us or it gives us multiple benefits. First thing, obviously, is the increase in the developer productivity, where we don't have to manage the infrastructure. Developers can focus purely on developing code. We have scenarios where there is low code or no code scenarios. We can integrate with the PaaS services or SaaS services, and also things like machine learning, and we can quickly build and deploy applications. So this gives a lot of benefit in terms of accelerating time to market. Your organization can build applications faster. You look at all those built-in providers or built-in connectors which are available. If you were to do that using, let's say, an API provided by that particular connector, it would take a lot of time. It abstracts all those kind of things, and we get this huge productivity boost by means of having this visual designers. And we also have capabilities where there is a lot of support in terms of intelligent monitoring and analysis as well. And finally, it also minimizes the risk, because things like security and advanced threat protection, they are provided as part of the capabilities of the cloud, and every cloud provider has this nowadays. So we don't have to spend too much time building these capabilities ourselves. Azure, for example, on many of the services, it's just a matter of selecting a checkbox or toggling a feature saying, I need security to be integrated, and you will have it out of the box. So with that, I conclude this session. Here are some of the references. Given links to the top level services, like whatever I showed in terms of various services, it comes from this first link, the Azure Serverless. That is like an entry point to all the different services you can use to learn more. Then there is Azure SQL Database, Azure Functions. I've given a link in terms of the scaling and hosting model, because the capabilities of Azure Functions, they vary based on the type of hosting model that we choose. I've also given a link for choosing the right kind of integration and automation service. I did talk about the Power Platform. That is also similar to the Azure Logic App. So the interface or the UI is similar to that, but the Power Platform is mainly for resident kind of users. It can be used within an organization, but when you want to do integrations across organizations, or you want to have capabilities like CI/CD, you want to have this different slots where you want to do, let's say, blue-green deployment kind of scenarios, then you need to use the Logic App or Function App. So this particular link, choosing the right service, talks about different options which are available, including this Power Platform, and when we should choose the right service. And then I've also given a link to the Azure Architecture Center, which is a very handy resource if you want to learn about different architecture patterns, which can be used not just with serverless, but various other kind of cloud architectures or cloud architecture patterns. I've put a link here to the Microsoft Learn, how to create a serverless application. This is a learning path which consists of 8 modules, and it's about 8 hours. You can go through this to understand how to build a serverless application using Azure Functions. And then I've given a couple of applications as reference architectures. First one is a scalable e-commerce web app, which uses the web apps, the Azure Storage and Function app to perform things like payment processing and stuff like that. And the next one is what I partially showed you, which is bursting to the AKS, from AKS to the ACI containers. So in this, I used exactly a similar kind of environment or setup, but instead of the SQL Server here, I use RabbitMQ in my example. So you can also refer to this link. And the source code for that demo onto the ACI is available on my GitHub repo. Thank you. Thanks for joining this session. The slides, whatever I used for this session, are available on SlideShare as well as Speaker Deck. You can find them over there. In case you joined in late, my name is Nilesh Kule, and I put in again the handles to all the social media uh, handles that I use or profiles that I have. It's very easy to find me on any of the platform using my first name and last name. It's quite unique, except for my blog, which is Hands-on Architect. So thanks once again. any questions, I would be happy to answer them if you have.
Yeah, thank you so much. Yeah, guys, if you have any question, please feel free to just speak out, or probably if you're shy, you can also put it in the messages. I think we have this one chat here. It's not really a question, but something from Alessio is saying there's also Azure MySQL flexible server in not entirely serverless, but base. Okay, I think it's about when we were talking about databases. So there is also possibly this option of Azure MySQL. I don't know if you agree, Nilesh, that it's about because
Yes,
if it
when
can
it
be
comes
used.
to the
Yeah.
databases on Azure, you have MySQL, there is Redis cache as well. There is Postgres as well. But I'm not very sure they offer serverless as an option. It might be available, but I'm not very sure about that.
Hmm.
I know for sure Azure SQL has the serverless. The other databases which are offered as database as a service, they might have this feature, which are maybe in preview at the moment.
Okay. Is there anything else, or maybe I think go first. I think if there is nobody else, go. So just one question on the on the Logic apps, right? So how I saw that there are some workflows and all, right, but like how complex can you go? Because in real life things fail, and like there can be errors, there can be retry, and the workflows can be really complex because you have to collect data from multiple sources and you have to connect to lots of things. So is there like an error retry transactions, like those kind of things are also available out of box?
Yes, you have all those capabilities. So you have like a typical ETL kind of tool where you have a success path and you have a failure path. So
Okay.
you can have these two kinds of output, and based on success or failure, you can trigger a different code path.
Okay. So okay, so you can go quite complex with that, those kind of different situations, scenarios, and what you want to do when this happens, what you want to do if that happens, like that,
Yes.
right? Okay.
Yeah. In fact, there was one, that's an interesting question you asked, Harpreet. We had a demo about, let me pull that out. If you go to our Azure Singapore YouTube channel, right, we had a
Okay.
session by one of the cloud developer advocate where she showed a very complex workflow which automated the email response to the meeting request. And they had built a workflow where, let's say, I send you a meeting request in Outlook and your calendar is blocked for today. So it will try to look 1 week in advance or 10 days in advance. I think it was configurable. So it will try to propose a time to the sender saying, I'm not available today. These are the time slots where I'm available. Do you want to book a meeting on that time slot? So you can do quite a complex stuff like that. So let
Yeah.
me show you that link. So you might want to have a quick look at that.
Yeah, I think that's quite good. So basically, you can extend the functionality that the software doesn't give into what you want to do. And really, like when I was listening to this, like what I think of is this IFTT, like the app we have, like it's really like a scalable version of that, right? So if this happens, you do this. If that happens, you do this, right?
Yes. So it is this session, the process automation and insights across Microsoft 365 data.
Okay,
So this is where the presenter, she showed how you can build a very complex workflow in the Logic app. And this was centered around the Outlook integration and the meeting. So basically managing your meeting response automatically.
cool. Okay, got it. So we'll have a look. Sure. So is there anything else anybody want to share or ask, or else we'll be closing? Okay. Going one, two, three. Okay. Okay. I think thank you so much, Nilesh. So it was really thorough. I think covered a lots of things about playing with serverless on AWS. It was really very detailed, and thank you so much. And all the links that you shared. So at least I think at least for the slides, we will also try to put it as a comments in the on the meetup page. So yeah, if there is nothing else or And if you last word, Lish, before we leave.
Yeah, it was great presenting for this meetup. I think this is the second time I'm presenting.
Yes,
It's
yes.
always a pleasure,
Yeah, I
presenting
think it was
this.
after 1 year. Yeah.
Yeah, I look forward to many more sessions with you guys. I hope it was useful. My LinkedIn and Twitter direct messages are open. So if anybody has any questions, I'm more than happy to take them later if you find some interesting stuff and if you have any questions around that. Thank you.
All right. So thank you. Feel free to reach out to Nilesh if you have anything. And with that, we'll close. Thank you, everyone, for joining. Thanks. Bye. See you next time.
Bye-bye.
Bye.